Magnetic energy is a growing resource across the globe for many reasons. It can be used in ways that influence millions of people, such as maglev trains and levitating cars. Not only that, but magnetic energy aids in collecting energy with solar panels and wind turbines, and is also in use in generators for households that are more efficient than conventional generators. But how exactly does magnetic energy work? Well, in its most basic sense, the energy of a magnetic field is induced when a current is run through conductive material near the magnetic substance, and the electrons of that substance begin migrating from one side, or pole, to the other. This definition leads many to the theory that a perpetual energy source can be created using magnets. However, it is just that, a theory. A perpetual energy source would be a green alternative that would be much more efficient and longer lasting than solar, wind, and water energies combined. Yet, a self-sustaining magnetic energy has never managed to successfully make it past the lab trials. So, can it be done? Ideas have spread about a perpetual energy source revolving around magnetism. This would pave the way for clean energy. There is a general consensus amongst scientists that such a resource is impossible, however, due to violations of the laws of thermodynamics. The first law of thermodynamics states that energy cannot be created or destroyed, only transferred and transformed. Therefore, a perpetual magnetic energy source would not adhere to this law because an input of energy would be required for such a machine to work. Despite this, many researchers have still diverged from this accepted belief to explore the ideas behind a perpetual magnetic energy source, and they have come up with machines that come very close to the concept. A new idea developed by researchers in France suggests that there are qualities of quantum mechanics that could justify the aforementioned concept of a perpetual energy source and render our current understanding of thermodynamics at least partially inaccurate. In physics, small particles such as atoms are viewed as tiny billiard balls. In contrast, quantum mechanics represents these particles as waves that overlap and interact with each other constantly. This quality, known as quantum coherence, allows electrons to flow freely through semiconductors. Researchers believe this causes another action called entanglement, in which the action of one particle immediately affects other particles. The idea for a perpetual energy source would be that atoms would continually interact in a give and take of energy and momentum, which would keep the energy in a system accessible instead of the energy dying out after a period of time. This theoretical idea could possibly solve the problem of a perpetual magnetic energy source because it would not violate the laws of thermodynamics. We are very hopeful about the development of the theory of quantum mechanics, which would rationalize the concept of a perpetual magnetic energy source and about the renewable resources that it would entail. Many people are doubtful towards the legitimacy of this theory, though. Nevertheless, we can look forward to a number of innovations that would improve our infrastructure and life in general within our global society. There have been multiple proposed designs and models for a potentially perpetual magnetic generator. The one given the most credit in recent years has involved a turbine, much like one in wind or hydroelectric turbines. The generator would require a burst of energy at first to get it started, but then there would be a series of permanent magnets along the circumference of the machine, each with the same charge as the opposing magnets on the machine, to keep propelling the turbine. Once it reaches the point that it can do this without any additional input of energy, it would be considered a self-perpetuating source. This is hardly more than a proposition, however. The generators only seem to consistently work when they are no larger than a bread box, which makes it not quite as valuable as everyone would like it to be. And with all of the conflicting ideas and arguments between scientists, it is pretty safe to say that using magnetism for perpetual energy has been put onto the back burner until further evidence supports that it could actually be worth the time and resources. That does not mean magnetism isn't extremely useful in the field of energy already, however. Magnetism has been studied and used as a way to supplement renewable energy sources, one of which being solar energy. Light has magnetic and electric properties, so light could potentially be used to harness a magnetic field in order to collect solar energy. A magnetic field is created when light passes through an object that does not conduct electricity. This produces energy equivalent to a strong electrical charge. By eliminating the need for semiconductors, this method of collecting solar energy increases efficiency by 10%. In addition to supplementing solar energy, neodymium magnets are used in both wind and hydroelectric turbines in order to reduce both the size of the gearboxes and the requirement for regular maintenance while increasing the output of energy. They are also used in superconductors to increase the amount of energy they can store and reduce their size as well. Another example of how magnetic energy is being used in the real world today is magnetic levitation trains. These high-speed trains being tested in other countries, such as Germany and Japan, use low-temperature semiconductor magnets to eliminate the friction of modern train wheels on a track. As of 2013, a maglev train was put in production for the purpose of connecting Tokyo and Osaka, which are separated by a total of 319 miles, by the year 2045. This train will cut the transportation time between these cities to about 67 minutes. The total expense of this project is intended to reach as high as $112.44 billion US. Although some of the researchers have expressed concern for the danger of these trains due to the high speeds, magnetic levitation trains could be a practical replacement for modern trains after modifications are in order. A couple other developing ideas for the use of magnetism in everyday life include levitation cars, which use repulsion forces from electromagnetic strips in the road to levitate the vehicle, and nanoantennas, which produce hydrogen gas through artificial photosynthesis. However, levitation cars and nanoantennas may not be available to the general public for quite some time. Even though there is plenty of skepticism towards the invention of a perpetual magnetic energy source, mechanical engineer John Christie and electrician Lou Britz have researched and possibly developed a residential magnetic generator called the Lutech 1000. After an initial charge from an outside source, such as a battery, this generator will continue to run by the energy produced from the attraction and repulsion of internal magnets. The batteries will eventually wear down after about 5 years, and the magnets will need to be recharged after about 1,300 years of use. Expected to be priced around $4,000 to $5,000, this generator has the ability to produce up to 24 kilowatts of energy per day, which makes it up to 500% more efficient than any single conventional gasoline generator. While most of these innovations in green energy using magnetism would be very costly compared to the original design due to the need for an increased number of and larger magnets, the long-term effects would be well worth the price. It isn't anywhere near perfect, but no energy source is 100% efficient. It will be an investment, and one that would need to pay for itself over time. However, the fact of the matter is, we're going to be running out of options before too long, and we need to continue exploring every facet we can find. That being said, it's hard to deny that magnets really have a large place in the field of energy, despite their relatively small name in it. There is no telling how many uses we have yet to find for magnetism in the future.